Live started.
Yeah, thanks. Yeah, welcome everyone to the live session. I'm trying to get access to the Google Sheet. In the meantime, if you have any questions, you could post it on the chat or in the Q&A.
Excuse me, ma'am. Ma'am, they are given access to the sheet. Can you please
No,
check?
the problem is they've given access to the IIIT email address, and I need access to my Gmail address. It doesn't recognize my IIIT email address.
Okay, ma'am.
I don't know whether they got my notification. I had requested.
No, ma'am. Right now, just now he gave access to it.
I got the notification in my IIIT address. I need it in my Gmail address.
Okay. Give me a minute.
Yeah. Yeah, welcome once again to all the participants. We're trying to get access to the sheet which some of you might have posted questions. In the meantime, if you have any questions, please post it here in the chat option, or you could unmute and talk.
Excuse me, ma'am.
Yeah.
Ma'am, can you check your Gmail ID?
Yeah, I'll do that. 1 second. Yes. Yeah. Yeah, I have it. Yeah, thanks.
Thank you, ma'am.
Yeah, while you're all waiting to post any questions, maybe I could get started with the session by trying to answer the questions for which learners had already filled up. Okay, so the first question is from Tushar Kansal from KNIT, and is written saying that some assignment answers don't match as taught in the lectures, and some questions are confusing with repeated options. That repeated options will not be there. Similar options will be there. That is just so that you know how to distinguish the right answer from the wrong one. if I'm not sure, Tushar doesn't seem to be here. If you can specify which assignment didn't match the week's lectures, then we can try to rectify it or provide clarifications. Please remember the videos for this course were recorded in 2017. Over the years, the course has evolved, and hopefully the TAs gave access to the folder containing all the slides to all of you. Those slides would be the updated slides with the corrections that were there, corrections of the errors that were there in the original slides that were used for recording. So please let me know if you don't have access to the slides. Yeah, I think this has been a common query even in the forum. There is Neeraj Babu who has written saying that because of some payment issues, he is unable to complete. He's completed the payment, but because it didn't reflect, he's unable to complete exam registration, and he's completed 8 weeks but can't write the final exam. So I think queries regarding this, you have to please contact the NPTEL administration. You can write back to them, NPTEL admin, and they will be able to help you out. Because exam is out of our control, we don't manage the exam registration. So please write to directly to NPTEL admin, and if you have done the payment on time, I think it should be possible to write the exam. Yeah, so the rest are similar questions or comments about the person being happy to join the live session. But those of you who are here, I see that about 12 of you are here. If you have any questions, please unmute and ask me, or post in the chat window. You could ask questions about any doubts that you might have that weren't cleared in the online forum, or any tips that you might need for the final exam. Feel free to post it or unmute and talk. Anybody with any questions?
Yeah, ma'am, as you said that these videos are recorded in 2017. So is there any plan on new videos and new recordings, new live sessions coming up with the new
Live
tool?
sessions we can do till before the exam, where I can clarify all the doubts if you're writing the exam. Recording, I don't know. Recording is a lot of effort, and we may not, definitely not for this edition of the course, because we are already almost done. No, now you are in week 10. So definitely not new recordings, but if you have doubts, specific doubts, see, in the past, students, learners who have writing the exam, we hold 2 live sessions just before the exam based on the number of registrations and the demand. But you could ask me very specific doubts, re-explain something, the notion of prime paths, re-explain active clause coverage criteria. So feel free to ask me very specific doubts if you want to understand. I will be happy to explain it to you.
Thank you.
Do you all have access to the slides, the common folder containing the slides of the course? I hope the TAs gave the link in the forum, course forum page. Do you need access to that folder? Has anybody tried to access the slides from the folder? So I'm posting a link to the slides here. See if you can get it. These contain the updated slides. If there are one or two errors, small errors in the video, and the slides also had errors, these would contain all the important updated slides. While you're here, please check it and see if you can open it. And if you're able to see the slides. Yeah, Shubhajit has asked a question, but I'm not sure if I understand it properly, Shubhajit. Indicator of what? Indicator meaning you mean a metric? Metric in software testing, or if you can please respond back.
Ma'am, I just get a questions from that Google and I'm trying to answer, but I unable to find that answer. Like which indicator we're talking that?
I don't remember such a question. These are assignments from previous years that you're accessing?
Yes, ma'am.
So if it is an indicator of a defect, then it would be option D. I mean, if it's an indicator related to testing, it should be option D, because B and C don't have any relationship to testing. It should be option D. But I'm not sure if this is a question that was there in this course. Please remember that there is also another 4 weeks course by Professor Rajiv Mal that runs on NPTEL on software testing. So I don't think this is a question from this 12 weeks course. But please do get it clarified, and because this question is incomplete and we don't use these indicators in the course. It could be from the other course, 4 weeks course. Anybody else? I've posted a link to the drive containing the slides. Please check it and see if you can access it. And feel free to pass this link to other learners, your classmates or friends who are enrolled for this course and will be writing the exam. This link will be available till the end of exam. And you can download the slides and use it for your learning. And if you have any other doubts, specific modules, feel free to unmute and ask or post it here. Because the purpose of the live session is to interact. There's no point in joining and being a silent listener. You all must ask questions and interact. Okay, so Sanika has asked the question of, can you please explain the notion of prime paths using the same example that you used during the lectures? So let me retrieve that file, slides. Yeah, I'll share my screen now. So prime paths belong to one structural coverage criteria on the graph. And it's a neat way of testing the graph for loops. Right, I hope you all can see my slides. I've just shared the PDF file containing the slides for structural graph coverage criteria. If one of you can confirm that you can see it.
Yes, ma'am. We're able to see.
Okay. Yeah. So the basic elementary one, so you take a piece of code, you take any program or program snippet. If you're using an IDE like Eclipse or Visual Studio or IntelliJ to write your program, you should be able to get a plugin along with that will give you the control flow graph corresponding to that method or that code. We forget about the variables and all, purely take the control flow graph and try to write test requirements that would execute every statement in the code, that would execute every branch, every transfer of control in the code, and that would execute all the loops. Meaningful execution of a loop in the presence of, so a loop will have loop variables. Loop variables will take values and they will dictate how many times the loop executes. Suppose you have a loop which says while initially I is 0, and then you say while I is less than or equal to 100, you do something. And inside the loop, if you have a statement like I plus plus, this would mean that the loop will execute 101 times. But inside the loop, if you have statement like I equal to I plus 5, where the value of the loop counter is going to get incremented by 5 every time, which means the loop is going to execute much less, right? It's going to execute 21 times. But in control flow graphs, we lose information about all the variables in the programs. We don't worry about the loop counter. We don't have information about the loop counter, other variables and all. But we would still like to test such that for every loop that is encountered in the program, we would like to test the loop such that we have test cases that will skip the loop, test cases that will execute the loop once, and test cases that will execute the loops as many times as I would want. We would like to test loops for these kinds of 3 properties, and that's exactly what prime path coverage gives. So I'll move on and go to this part, prime path coverage. So we first understand what the definition of a prime path is. To understand what a definition of a prime path is, you should know what a simple path in a graph is. I hope you all remember what a path in a graph is. It is an alternating sequence of nodes and edges. Sometimes, if it's a test path, it will always begin in an initial node, end in a final node, such that the alternating sequence of nodes and edges are connected by actual edges in the graph. The edges incident on a particular node is what is alternating between 2 nodes. So, specific kind of paths that we would be interested in are simple paths. A simple path is something where in that path, along the way, inside the path, a node that already occurred earlier in the path will not repeat. So the first node can be one node. The last node can be the same as the first node. That is allowed in simple paths. But in between, no other node that occurred earlier in the path will occur once again. So a simple path is a path in which no node appears more than one. The only exception is the first and the last node. The first node and the last node can be the same. So the first node can appear once again as the last node. Otherwise, no other internal node will appear more than once. So this is a simple path. What is a prime path? Prime paths are maximal simple paths. That is, they don't come as a proper subpath of another simple path. Is this clear? So we say they are maximal simple path. Largest length, they are simple paths. So they don't come as proper subpaths of any other simple path. Then we say prime. Such a path is called a prime path. So you take this graph, it's the same graph as used in the slides. This is a small graph, abstract. We don't know what is the program that it corresponds to, but that doesn't matter now. So you see simple paths, you go in the reverse order, start from these 4. Singleton 1, singleton 2, singleton 3, singleton 4. So these are paths that contain only one node. Then you look at all these. These are paths that contain one edge, that is paths of length 1. And similarly, these are paths that contain 2 edges, paths of length 2. And these are all paths that contain 3 edges, paths of length 3. If you see, all of them are simple paths. They satisfy the definition of a simple path. No internal node appears more than once. So first and the last node are allowed to repeat. So in fact, almost all the paths here, one appears as the first node, one appears as the last node here. So here again, one is the first node, one is the last node. It still qualifies as a simple path. Whereas this is a simple path where 2 is the first node, 3 is the last node, and no other node repeats. So that's also fine. In this, I want to take only those that are prime paths. So let's go back and look at the definition of a prime path. Prime path is a simple path that does not appear as a proper subpath of any other simple path. So if you take something like this, if you take something like 413, this is a simple path, right? If you observe, 413 appears as a subpath of this path, 4134. It completely appears inside this. So path 413 will not qualify as a prime path. Similarly, path 412 will also not qualify as a prime path because it appears inside this larger simple path. Similarly, 241 will not qualify because it appears as inside this. And all these smaller paths will appear inside, for this example, will appear inside a larger path. So if we take maximal length simple paths, then for this graph, it will be only these paths. None of them will appear inside the other, so all of them will get listed. So prime path coverage says, first you take the control flow graph of a program. Take a program, draw its control flow graph. And for that control flow graph, generate all the prime paths. There is a module on which tells you an algorithm to generate all the prime paths. That will be your test requirements. That will say that all the loops in the control flow graph, when taken as a set of prime paths, will be executed once, will be skipped once, and you can execute a loop as many times as you want. So let's look at a larger example. So let's take this one on the left. I hope you can see the control flow graph on the left. So there are 7 vertices, 7 nodes. Node 1 is the initial vertex. Node 7 is the final vertex. Because we are studying prime paths, we are interested in looking at whether there are loops in the graph or not. There is a loop in this graph. This is the loop, 5, 6, 5, 6. There is a branching at node 1 because there are 2 edges that go out. There is another branching at node 3. There are 2 edges that go out. These 2 probably correspond to if statements. The loop here is at 5, 6. So if I have to enumerate prime paths, I should first check simple paths, and then I should look for simple paths that don't come as subpath of any other simple path. So if we enumerate prime paths for this graph, you will get 9 of them. So 1 second, I will show you how to intuitively enumerate. I'll just share my screen once again to include my drawing board.
Excuse me, ma'am.
Yeah.
What is the topic, ma'am, now you are taking?
There was
Because
a question
normally-
of please explain prime paths, and that's exactly what I'm taking now. If you have a doubt, just hold on. I'll finish this in 5 minutes, then we can move to your question.
Okay, ma'am.
So can you see my writing board and the graph in the slide?
Yes, ma'am.
Yeah, so let me just redraw the graph on this. This is some control flow graph that we have, and we would like to enumerate all the prime paths. The course teaches you how to systematically enumerate all the prime paths. But once you practice, you will know how to intuitively enumerate also. Most of the prime paths, you will get it right if you follow this intuition. I'm just copying this control flow graph once again onto this writing board. And please remember, there is a loop here, right? So this is a loop. The part that I'm highlighting is a loop in the graph, in the CFG. And I would like to enumerate prime paths. So let's go ahead and enumerate prime paths for this graph. There's maximal simple paths. So let's try. So 1, 2, 3. Sorry, this should be 7. I'll just write the label here. 1, 2, 3, then 4, 7. Is this a simple path? The answer is yes, because if you see, no node appears more than once here. And can this simple path be made larger while retaining the property that it continues to stay simple? The answer is no. So this is a maximal simple path. So this is a prime path. So let's take something like 1, 2, 3, 5, 6, 5, 7. So is this a simple path? The answer is no, because if you see, node 5 is an internal node that appears once. So this is not a simple path. If it's not a simple path, it's not going to be a prime path also. Right? Similarly, if you, so we can't take this. So the first one is a prime path. Then what could be other prime paths? The other prime paths could be these 1, 2, 3, 5, 7. 1, 2, 3, 5, 7, because it's the maximal simple path. This is a prime path. Then 1, 2, 3, 5, 6. If you do 5, 6, 5, like we did above here, it violates the condition of a simple path. So you should not go back to 5. This is a maximal simple path. This is okay. And then what else can you have? You can have 5, 6, 5. You can have 6, 5, 6. Then what else can you have? You can have 6, 5, 7. These are all proper paths, right? There is no problem. You should not have 5, 6, 5 because that will mean something is repeated. So let's count. 1, 3, 4, 7 is a prime path. 1, 3, 5, 7 is a prime path. 1, 3, 5, 6 is a prime path. 5, 6, 5 is a prime path. 6, 5, 6 is a prime path. 6, 5, 7 is a prime path. Now you can ask yourself, is there any more? Are there any more prime paths for this graph? There are. So for example, you could reach this loop at 5, 6 by using the other way, right? You can do 1, 2, 3. Earlier we did 5, 6, right? So you could do 1, 2, 3, 5, 6. That is covered. So can you do 1, 2, 3, 4, 7? That's covered. What about 1, 3, 4, 7? That's not covered. So let's include that as a prime path. I'm just doing it intuitively without using the algorithm so that we get a hang of what it is. So 1, 3, 4, 7 is a prime path. 1, 2, 3, 4, 7 we've already listed. So how many have we counted now? So far we have counted 7. Are there any more prime paths? We'll have to see. So one way to systematically enumerate all the prime paths would be to start with paths of length 0, which is the nodes. Then go to paths of length 1, which are the edges. Then expand them to paths of length 2, which are by adding at any point in time, extending it by one edge, and move on till you get paths. In this case, the graph has 7 nodes. If a graph has n nodes, the maximum length of a simple path can be n-1. Otherwise, a node will repeat, which is not allowed in a simple path. So this is one way to enumerate prime paths. Now, if you take some prime paths, like for example, if you take this one, right? If you take this one, 1, 3, 5, 7. If you trace it back in the control flow graph, what it does is this does the job of skipping the loop 5, 6, 5. Are you able to understand? This does the job of skipping the loop. If you take this path plus...
Why we are skipping 5 and 6, ma'am?
No, that's what. We're not skipping 5 and 6. If you take these three together, these three together, we enter the loop. And you can use 565 and 656 to execute the loop as many times you want. You're able to understand this?
Yes, ma'am.
And when you say, okay, I've executed the loop twice, thrice, for whatever reasons you might want to execute, when you want to leave the loop, you use this one. Leaves the loop.
Ma'am?
Yeah.
Ma'am, but the path definition is that you reach from the, you start from the starting node and you should reach the destination. So in the path 1, 2, 3, 5, 6, we don't reach the final node.
That's a good question. So remember, we are now only writing prime paths test requirement. The path definition that you are talking about is the definition of a test path. So there are two things. When we do prime path coverage, we first write the test requirements for prime paths. I'm only writing test requirements. There, the prime paths can start from anywhere and end from anywhere. Now, the next step is to write test paths that achieve prime path coverage. For that, I cannot take, as you say, 1, 2, 3, 5, 6. It doesn't qualify as a proper test path, right? So I have to add it by saying 1, 2, 3, 5, 6, 5, and maybe 7, or maybe execute the loop 1, 2, 3, 5, 6, 5, 6 as many times as I want, and 5, 7. So what we have listed here, these are test requirements, TRs as we call it, for prime paths. Your question is related to test paths, right? To
Yes,
get test paths, we have to extend the test paths that satisfy prime paths coverage for prime path TR will begin at an initial node and end at a final node. You have to extend prime paths to do this.
ma'am. So in that case, if we consider the path 1, 2, 3, 5, 6, 5, and 7, so won't that node 5 be repeated twice?
For test paths, it's okay, right? It's not a prime path. Please remember, the distinction is while writing test requirement, we have to capture all prime paths. They cannot be repetitions. They have to be maximal simple paths. So I saying, okay, take this graph. This has so many prime paths. That will be test requirements. Now, you have to write paths that satisfy the prime paths. Test paths need not be prime paths themselves. They can be any valid test paths are not always prime paths themselves. Test paths will be a prime path. This is all right because our test requirement was that of a prime path. The requirement can be met by any test path, which will have repetitions. In fact, you will not be able to write test paths without repetitions. And that serves our intuitive purpose of understanding to say that prime paths achieve loop coverage, right? Because I can write test paths that go through the loop once, twice, thrice, as many times. And if it goes through once, twice, thrice, 4 times, that many times the internal vertices are going to repeat. So it is perfectly fine to do that. I hope this answers your question.
Yes, ma'am.
Any of you could email me also if you have doubts. Yeah, anybody else for any question? Yeah.
Excuse me, ma'am.
Yeah, please tell me. Yeah.
Ma'am, can you hear my voice, ma'am?
Yes, Vishnu Prashant, right? I can hear you. Yeah.
Yes, ma'am. Ma'am, for exam preparation, what sort of topics we need to give a more preference, ma'am?
So exam, there will be one question on graph coverage criteria, both structural and data flow. So focus on that. It's all MCQ type. So, and then one large question on logic coverage criteria. So for structural graph coverage criteria, I will give you the control flow graph and data definitions, data uses for nodes and edges, and ask you questions very similar to the ones that you've done in your assignments. Write test requirements for prime path coverage. Can you give me the test paths that satisfy all definitions coverage, things like that. And there will be one set of large question on logic coverage criteria, where I'll give the logic, the predicate, the truth tables, and ask you to write when does a clause determine a predicate for each of the clauses, then on active clause coverage criteria, CACC, RACC, GACC. So there will be at least 10 marks for each of these. At least 10 questions. So each question carries 2 marks, 50 questions, 100 marks. That's the pattern of the final exam. So there will be 10 marks on control flow graphs, data flow coverage criteria, at least 10 marks, like a group question. There will be 1 control flow graph given and 10 questions. Similarly, for logic, there will be 1 predicate given and at least 10 sub-questions. So if you do these 2 right away, you've got more than 40 marks.
Then for assignment questions also will be included, ma'am?
Sorry?
Because the assignment questions will be included or
there will not be many repetitions, but the questions will be similar to what you have in the weekly assignment. They won't repeat exactly, but it will be very similar.
Okay, ma'am.
So, and there'll be
For
one
taking
question you
notes,
testing also. Sorry?
ma'am, for notes, how to take it, ma'am?
I
What
just
are the
uploaded link to the drive. You joined late. I will upload the same thing once again. The slides are all there here. Plus the video
Because more number of videos there, ma'am. That's why.
See, these are corrected slides. All the important slides are available in this Google link. You should have viewing permission if you have this link. I've just posted the link again in the chat box.
Okay, ma'am. With the help of this link, we will get the notes or not, ma'am?
Slides, all the slides you will get with the corrections done.
Okay, ma'am. Okay, ma'am. This notes
You can
itself
use this
enough for
the video
preparing
and,
exam or?
Sorry, Vishnu.
This notes itself enough for preparing a exam or we need to prepare additional also, ma'am?
No, notes plus remember to solve all the assignments. Even if you have not submitted it while preparing for exam, solve all the assignments.
Okay, ma'am. Okay, ma'am.
We'll try to have one live session 1 week before the exam so that you can use it for clearing doubts.
Okay, ma'am.
Yeah, so Jayashri has asked the question, exam questions will match assignment questions? No, I don't think so, but they will be very similar to the assignment questions. They will not repeat once again.
Okay, ma'am. How many hours of exam will it take place, ma'am?
I think that the office decides, no, NPTEL of 3 hours, I think. You will get 2-3 rough sheets, and that's all you need for this exam. The whole exam is MCQ.
Okay, ma'am.
Anybody else had any doubt?
Ma'am, on yesterday's session, what topics you were taken, ma'am?
No, yesterday it got postponed to today. We didn't hold the session. Sorry about that.
Okay, ma'am. Okay, ma'am.
So it got postponed to today because I couldn't come back. I was stuck on the road in traffic and couldn't come back.
Ma'am, for problems and all, which websites, ma'am, we can refer it?
The textbook for the course is there, no? Majority of the course is from the textbook. And
okay,
the PDF of the textbook is available. I can put a link, and an older version is available. You can use that. The textbook has exercises.
Okay, ma'am. Ma'am, for NPTEL, how many marks we need to take for getting passed, ma'am?
You should do at least 8 assignments.
Okay, ma'am.
8 weeks assignments minimum. If you do more than that, then it's good for you because the best will be taken. And then the final exam. And the weightage, I am not very sure. I think it's 75-25. And you should get 40 total.
Okay, ma'am. Okay.
So look at this page, the page that I have put here. This will give you a link to the course textbook page. Look at the student exercises in that and try to solve it. It will help you a lot.
Okay,
yeah, I think the question in the chat also says the same thing. I think 40 marks is pass, but try to aim for more. You should get gold or elite or things like that, not just pass.
Okay, ma'am.
Okay, this SB, somebody called SB wants to know active clause coverage criteria. Just give me a minute. I will open those slides and try to explain it. Yeah, I have the slides. I'll share my screen. Yeah, I hope all of you can see my screen.
Yes, ma'am.
Yeah. So let's understand this active clause coverage criteria. Let me just use the writing board. You specifically wanted help with active clause coverage. So in general, I will have formulas like this, like the one that you see on the slide here, like this. Right? There will be some bits and pieces. So let's call it as a predicate. And that will have something. So let's say is x less than or equal to y, then it will have f of y is greater than 5, and then it might have some c, right? So what we try to do is we try to group them. So let's call this part as A. This is one clause. Then let's call this whole thing as B. This is the next clause.
Excuse me.
Yeah.
Can you have any other links for preparing exam notes, ma'am?
Any other links? I mean, I've given you the slides, I've given you the book. Try to do the student exercises and do all the weekly assignments. Even the ones that you haven't done, try to do them.
Okay, ma'am. Okay, ma'am.
So if you try to segregate it, you'll get clauses are A, B, and C. So the most simple coverage criteria would be cover the predicate. Make the whole predicate somehow true and whole predicate somehow false. Assign values. That's this whole predicate P. But in that process, you may not even assign values to certain clauses in the predicate. It might not, you might just ignore it. In fact, the compiler optimization will ignore it. So what we try to do is, okay, we say we'll do clause coverage, where we take each of the clauses, like in this example, there are 3 clauses, and assign true, make one first clause true and false, the second one true and false, the third one true and false, you go on like that. But in this, we saw through examples like this, that it may not even make the whole predicate true. So when you try to do predicate coverage, you may not exercise the clauses. When you try to do clause coverage, you don't exercise the predicates. So what is the way out? Can I test in such a way that each clause is made true once, false once, and that also makes the predicate true and false once? So that's where active clause coverage comes into picture. So the core thing is, my goal is to make each clause true and false in turn and see how it influences the truth or falsity of the predicate. So that's what we call as a clause determining the predicate. Like, for example, if you take something like this is a small one, A or B. Suppose, for example, assume that A is true. A could be something like this. A could be x greater than y, x less than or equal to y. Whatever it is, assume that A is always true. Okay. Then what will happen to this predicate P? It's the predicate P is A or B. If A is always true, then irrespective of what value B takes, the predicate P is going to evaluate to true because of the semantics of the OR operator. We are not even testing how B affects the predicate P. So we would like to do that. We would like to take a predicate, take each clause in a predicate, and see how it affects the truth or falsity of the predicate. So that is what is called a clause determining the predicate. So I take this predicate. Suppose I want to know, there are 2 clauses, A and B. Suppose I want to know how does clause A determine the truth or falsity of the predicate. So I must ensure that the other clause, in this case, the clause B, takes value such that if the value of A changes from true to false or from false back to true, the value of P also changes from true to false or false back to true. Right? So if I make B false, this other clause B false, then the whole predicate is A or B, B stays false. So if A becomes true, then using the semantics of the OR operator, the predicate P will be true. So if A becomes false, then using the semantics of the OR operator, the predicate P will become false. So in this case, we say A can determine the predicate P. So in general, a predicate can have more than one clause. So a predicate can look like this. P can have some clause A1 and then some logical operator. This could be and or. And then another clause A2, another logical operator. It can go on like this, and then there can be AN. So each of these clauses, AIs are the clauses. So each of these clauses, you want to say AI determining a predicate, meaning the other clauses, AI determines P if the other clauses, all the other clauses, how many ever they are, 1 or 2, doesn't matter. All the other clauses AJ, where J is not equal to I, take values meaning take true or false values, such that AI influences the truth or falsity of P. So if AI becomes true or false, P also changes from truth or false values. It need not be that when AI is true, P is true, and when AI is false, P is false. It could be the other way around also. But when AI changes from one value to the other, between true and false, P will also change from one value to the other, between true and false. So this is what we mean by a clause determining a predicate. We would like to call this clause as the major clause. Each clause in a predicate will take turns to become a major clause. All the other clauses will be called as minor clause. So in this example, for example, the first one here, there are 3 clauses. So each of these 3 clauses can become a major clause. Clause A is a major clause. And I would like to assign values to B and C as true, false, such that A will determine the predicate. We call B and C as minor clauses. And then in the second round of testing, I can make B as the major clause, and I would like assign values to A and C such that B determines the value of the predicate. Similarly, C can be the major clause, in which case the minor clauses A and B, I should assign values such that C will determine the value of the predicate. So this is what is given here. Given a major clause CI in a predicate, we say that CI determines the predicate P if the minor clauses have values such that changing the value of CI changes the value of P. Is this clear?
Excuse me, ma'am.
Yeah.
Ma'am, can you, can you give the topic headings for problems, ma'am? Because both theory and problems were mixed, ma'am. That's why for problem headings alone, can you display in the chat, ma'am?
For the exam, you mean?
Ma'am, for preparing, because both the problems and theories were mixed, ma'am. That's why for separate learning, I'm asking, ma'am.
Yeah. I understand. But 1 minute. So, who is currently talking now? Vishnu.
Yes, ma'am.
Let me just finish this part and then come to your question.
Okay, ma'am.
Yeah. So, so I hope you understand what this clause determining a predicate is. Now we go to active clause coverage. Active clause means each of the clauses in a predicate. Predicate can have 2, 3, 4 clauses. Take turns to become the major clause. And then we call that clause as the active clause. So for each predicate and each major clause in the predicate, choose values for minor clauses such that the major clause determines the predicate. Make the major clause true once, make the major clause false once, and see how the predicate becomes. That is what is active clause coverage. So maybe we'll take that example that comes later in the slides, the larger example, and then we will see. Yeah, so if you take this predicate, A and B or C, first question you must ask is, how many clauses are there? There are 3 clauses, A, B, and C. What are the operators? And is here, or is here. You will always be given this truth table. And I hope all of you are comfortable with reading the truth table. We just read a few rows and see. How do you read second row of this truth table? second row of the truth table can be read as A and B as clauses take the value true, T for true. C as a clause takes the value F, false for F. And I use the semantics of the operations and or, and I realize that the whole predicate A and B or C in this case becomes true. So similarly, how will you read row 7 here? How will you read it? You will say A and B take false, C takes true, and when A and B are false and C is true, the predicate P evaluates to false. So you will be given this predicate, you'll be given the truth table for the predicate. The predicate has 3 clauses. I'd like to make each of these 3 clauses as a major clause and test for active clause coverage. So let's say I make A as the major clause. I would like to assign values to B and C such that the truth or falsity of A determines the truth or falsity of B. That part is not there in this slide deck, but the next slide in the same set will say how to assign values for B and C such that I get A to determine P. It will say assign A true once, assign A false once, XOR it and all that. So suppose you figured out that B and C take certain values such that A is true. In this case, B or C will take true such that A can determine P. So you determine that condition. And then from this truth table, you have to say, suppose I assign A, my major clause, to be true once. I want B and C to take values such that A can determine the predicate P, right? So which would be the rows that you would choose from the truth table? Here, that is what is worked out for correlated active clause coverage criteria in this slide. So I take A to be true here, here, and here 3 times. A is false, rows 5, 6, and 7. I'm reusing the row numbers here. Answer options will also reuse these row numbers in the truth table, right? So now CSCC can be satisfied by picking any of these rows. I can choose row 1 and row 5, or row 1 and row 7, or row 3 and row 6. Any pair from the top set matched with any row from the bottom set as a pair will be fine. Why is it fine? If you see in the first 3 rows of the top set, all the 3 times A takes value true. And all the 3 times the predicate P also takes value true. And in the bottom set, 5, 6, and 7, all the 3 times A takes the value false. All the 3 times the predicate also takes the value false, right? So I can pick up anything from here and anything from here. That would any row from the top set, any row from the bottom set, that would satisfy my condition of A, clause A as the major clause determining the predicate P, and B and C taking values such that A for sure determines the predicate P. Similarly, you can do an exercise for B determining the predicate P, C determining the predicate P. Each clause takes turns to be the major clause or the active clause, and the minor clauses take values such that the major clause can determine the predicate P. There are 3 variants. One is general active clause coverage criteria, where we don't put any condition or requirement on the values the minor clauses can take. That's why it's general. But general, we realized, is not very useful. Correlated says, no matter what happens, ensure that the minor clauses take true, false values such that the major clause determines the predicate for sure. So that is correlated. The next one is restricted. Here we say there is one particular clause, which is the major active clause. Choose identical true, false values to all the minor clauses. That's why the English word restricted. It's very restricted. It chooses matching true, false values for all the minor clauses in both the cases, as when major clause becomes true and as when major clause becomes false. So these are 3 variants of active clause coverage criteria. I hope that answers your question. Yeah, okay. So now let me go back. So Jayashri says overall exam 40, considering assignments, final exam 40. I think the weightage is 75-25 for the 40. 75 for your final exam and 25 for the assignments. So you have to do well in the final exam. One simple trick to do well in the final exam is revise all the assignments, solve all the weekly assignments. So now coming back to answering Vishnu's question, which would be direct memory recap theory questions, which would be problem solving questions. I'll repeat it. There will be problem solving on graph coverage criteria. Please remember that. There will be a problem solving question on graph coverage.
Excuse me, ma'am. Excuse me, ma'am. Wait,
yeah,
ma'am.
yeah.
I'm taking notes, ma'am.
Yeah.
Ma'am, can you repeat it slow, ma'am? I'm taking
this
notes.
will be recorded and put back also. So I will repeat it for your sake. But what I'm saying is there will be problem solving questions on graph coverage criteria, structural coverage and data flow coverage.
Okay, ma'am.
And there will be a set of problems on logical coverage criteria, the kind that I just explained.
Yes, ma'am.
There will definitely be, and there will be one set of problems on mutation testing, modules that you would have just seen in the previous couple of weeks.
Okay, ma'am.
Okay, theory questions will come from first week where you learned the basic concepts. And last week will also be purely theory.
Okay.
But for problems, prepare these 3 major modules and you will be fine. Yeah, so Gayatri, I am not sure which you joined late or what. You want the drive link containing the slides? I will repost it once again, if that's what you're asking for.
That's all, ma'am. Or any other problems, ma'am?
No. This is about it and symbolic execution also.
Symbolic executions means, ma'am?
You're going to do it. It's not yet done in the course. I think in your course, it will come in week 11.
Okay, ma'am.
So we will do one live session before the exam. When is your exam date?
I think on October last end, ma'am.
So we will do sometime around the 3rd week of October, one live session. Office will post it. Join without fail and ask all your doubts. Like today, others asked, like that you must ask doubts. Explain this once again. How do I solve this problem? You must ask doubts like that. You mustn't ask doubts like which are important questions. That doesn't make sense. You'll revise and come. And any doubts that you want in terms of re-explaining, I'll re-explain it once again.
Okay, ma'am. When you will start the next live session, ma'am?
Yeah, so we can have it in October 2nd week. That will give you 2 weeks before your exam. By then, all your lectures will also be over. All the 12 weeks will be over.
Okay, ma'am. Okay.
So if there are no more questions, we are nearing end of 1 hour. So I'll stop here, but we will have one more, definitely 2 more before the exam. So pass it on to your friends, this information, and come back for those live sessions with your doubts. And you could also post it in the program. I'll be able to answer it. The TAs are also there. They will also answer it. You can also send me a mail.
Okay,
so
ma'am.
I will post my email ID. You can send me a mail if you have any doubts. I'll try to respond back while you're preparing for the exam. And we'll do one more session, live session before the exam.
Okay, ma'am.
So
can you give the date for next live session, ma'am?
I have to ask the NPTEL office, but we will have it in the 2nd week of October.
Okay, ma'am. When you will post the videos, ma'am? Live
video?
session. Live session videos.
Usually post it within a day or 2.
How we will watch, ma'am? At where you will post, ma'am?
In the course page.
Ma'am?
It will be there in the course page.
Okay, ma'am.
You've seen the course page where assignments are posted and the live session was announced.
Yes, ma'am.
Same page, it will be there.
Okay.
Yeah, so maybe we'll stop here. We will meet again on in October and pass the information to your friends in the college if they would want to join.
Thank you.
They can join the next live session. So, Mr. Akshay, we will stop here. Is that okay? They might have left the NPTEL office people, but doesn't matter. So feel free to write to me for any doubts and come back for the next live session and tell your friends also. So I'll end the meeting now. Thanks for joining.